roughly right. All right, let's see. Which one again?
310, number 9.
All right. So first part of this problem is just to find the linearization of this at 0, right? They want you to verify that that's the tangent line to this function at 0. Some of you guys desperately don't want to let go of how this book treats this idea as brand new. So you want to memorize f of a plus f prime of a, whatever, that's fine. But it's just finding a tangent line. There's nothing new in that regard. We're just using it for more stuff than we did before. The second part of this question is what's freaky. And just to point this out, we're going to do this problem, but just to point this out, they have a whole little example of this. Let's see, where to go. Here. Okay, so we'll kind of redo this. I think they do the work, yeah, down here at the bottom. Okay. Do you see how they have a function and they're approximating it? So this is the approximation to this function. So if I want to know how far off my approximation is from my actual function, like on the test, on the quiz, how would you figure out how far apart your approximation was from the actual value? You'd figure out the actual value, and then you would
take the actual value.
Take the actual value.
Minus.
You would subtract, correct? You with me? Now the answer might come out negative if you have to subtract the smaller from the bigger, so I'm going to put absolute values on it just to make sure it comes out positive. I just want to know how much off I am. If I'm over by 0.5 or under by 0.5, how off am I should be 0.5. It shouldn't matter which way I go, yes? So you see that's what this says. This says the difference between the function and my approximation. Absolute value, so it stays positive, I want that to be less than 0.5 in this example. I think in the problem it said less than 0.1. Yeah. Now, another thing you have to remember, and again, it's one of those things that's very technical, very kind of, and then it's not a huge idea. So it kind of almost doesn't matter, but I want you to be able to do the problems. Do you guys remember how to rewrite something like this? This is desperately trying to be a 1, poor little dude. Not an 11, there we go. Do you guys remember how to rewrite that without absolute values? Some of you guys are like, yeah, you just take the absolute. No. How do you capture the idea without you writing absolute values?
Plus or minus?
Not plus or minus.
Minus 1.
So listen. Yeah. Whatever that number is, can somebody give me, all right, what if I do this instead? All right, I don't want to spend tons. Can somebody give me a number that I could plug in here to make this a true statement? 4. Can somebody give me another, what's the largest positive number you could put in there?
7.
Weird question.
7.
6 point, you with me?
Yeah.
If I try to plug 7 in there, does it work?
No.
And you're like, that's what we meant, Jeff, when we said 6.9. Okay, I'm good. Okay. How about negative numbers? How far down negative can you go? Oh, okay, so whatever's inside can go up to, but not quite to 7, and down to, but not quite to negative 7. So I can always rewrite absolute value of stuff less than something as a sandwich. I always think of a less than as a haunted house. Stay close to me. Holy shit. Just go in. You want to split up. I've seen it in horror movies. Stay close to me. Yes. Greater than I call a restraining order. Stay the hell away from me. So when you grab that, it's going to look like this. I'm gonna be in the middle, everything's gonna be away from me. So if I come back to what I had originally, whatever's inside can go up to 7, down to -7, and then you can solve. Add 1 to everything. Yes? Remember this stuff? Does it sound a little familiar?
Sort of.
So, coming back to our problem. No, wait, what's the function we're working with?
The fourth root of 1 plus 2x.
Fourth root of 1 plus 2x. And then what's the approximation? I could just look at it.
1/2 x plus
1/2 x plus 1? Good lord. Okay. So I want the difference between my function and my approximation to be less than 0.1, right? How can I rewrite that? That's got a lot more crap in it, but who cares? Stuff, absolute value less than 0.1. How do we rewrite that? What can it go down to?
-1.
Negative 0.1. And what can it go up to? And what is it? All this crap. Yes? Cool. Yeah. So now you add this dude to both sides. So you'll get 1/2 x plus 1 minus 0.1 is plus 0.9. Is that cool? Less than 1 plus 2x to the 1/4. Less than 1 plus 1/2. So it'll be, you can do it, Jeff. 1/2 x plus 2. This is already a 1 here. I'm sorry. It's a 0.1. You can almost see it, Jeff. Good job, buddy. 1.1. Stop for a minute. I love you guys. Such a small little idea. Not that big of an idea. So I just want to know, when is this guy caught between those two? What values of x makes this true? What idea is this overly technical process catching? I want to stay close to my x value that I built it around, or else my approximation gets bad. That's all this thing is really saying, just in a hyper-technical way. So if in my graphing calculator, I put in here 1/2 x plus 0.9. I put my function. And then I put my other function. I call this my ceiling and my floor. So here's my floor. I'm sorry. There's my floor. There's my ceiling. And there's my function. So I want to know, when does it stay in the house? If I graph this, I'm going to hit zoom 6 to graph. So there's my floor, there's my function, there's my ceiling. Zoom in, yeah, enhance. And by the way, isn't this a 1/4 power? Can somebody tell me what the lowest x could be for the function in the first place? 1 plus 2x equals 0, that's the least it can handle, right? This is a 4th root, yes? And 1 is 1 plus 2x equals 0? Negative 0.5, okay. So let me look at this again. Around negative 0.5 is where my red line starts to exist, yes? Look, I was gonna walk over there because my brain is thinking you can see the iPad, but this is your graphic calculator. Zoom box is the coolest thing ever. It's just like those fake CSI shows. I zoomed too much, but that's okay. Zoomed over too big of an area, doesn't matter. I'm gonna make sure I capture it all. Everything's happening in there, yes? Because do you see this red line has left the room? I have a room in the Tower of Pisa, yes? It's leaning a little bit. But that red line is broken through the floor at that point. So let me zoom in and see, when is this red line contained? Do you see how it's, do y'all see it now? Can you see how it's contained there? Let's zoom in some more. Okay. Jeff, calm down. No, I don't give a shit. So I want to zoom in some more. Because now I can see what's going on. Let me zoom in on where everything's important. No, Jeff, you're so good at this. Zoom blocks. You do it. There you go. Come over here. Okay. I want to make sure I capture everything. So I got where it busts out the floor, and I got where it comes into the floor. I think. Let's see if you did, Jeff. You did. There it comes in, and it goes out. Now can you see better? Between the black line is the ceiling, the blue line is the floor. And I want to know, so if I go anywhere past this x value this way, or past this x value that way, my approximation is off by more than 0.1. Are y'all with me? Anytime I do an approximation, I want to know, when is that approximation good? And then the next question is, well, what makes it good? Well, in this problem, they're off by 0.1, they're okay. If any of you have done ever any machining or anything, you have tolerances. Your holes don't have to be exactly perfect, but they have to be within something. If it's too big, it's going to jostle. If it's too small, the damn thing's not going to go in there. But it's got a little bit of tolerance to it. Thank the gods. Close enough for government work. Okay. So how the shit do I find that? I find the intersection here using the intersect thing. Enter, enter, enter. So it first enters at this value, negative 0.36, whatever the shit. That's when it starts to be within 0.1, and then you can do the same thing over there, see when it stops being within 0.1. Yes?
So you don't want us to do algebraic?
Oh my God, no. If you've tried, I'm sorry. My God, there's no way to solve this. There's no way to solve this. How do you get rid of the 1/4 power? Don't you raise everything to the 4th power? In which case, these x's are stuck. How do you unstick them? Take the 4th root. Take the 4th, do the 4th, take the 4th root. Take the, whack-a-mole, right? It's never going to stop. Dear God, no, no. This is where, huh?
How does the calculator get it?
Oh, we're going to learn later this semester. You're like, damn it, why did I ask? In fact, section 4.8, we're going to learn some shit. We're going to learn the actual algorithm the calculator uses to do certain things. Maybe not exactly this. Yes?
So, the last line is a answer. Now you just gotta say when a.
No, I graphed this, that was my floor.
Yeah.
I graphed this, that was my function. I graphed this, that was my ceiling.
Right.
And how do I get the answers? In the calculator, do the intercept.
Oh.
So, we all know this. You all know this. That if I have a curve, and I have a tangent line to a point, the further I go away, the worse the approximation that tangent line provides gets. Yes? All this problem is doing is saying, hey, let's get technical for a second about how close I need to be. How close you need to be depends on how right you want to be. If you're like, I can be off by 10, then maybe you can be out to there and over there. If you're like, I want to be off by 0.01, then you're like, okay, here. The little TIE fighter gets further away. The little TIE fighter. And maybe. So again, this is a hyper-technical problem illustrating the idea of being close gives you a better approximation. That idea, we know. We've talked about that. You all basically you understand it. This is very technical about graphing, setting up the inequality so you know what to graph. Okay. All right, enough of that. That's just this little throwaway little problem. Okay. Still got to do it, but it's nowhere near as important as the other stuff. Anything else from homework stuff, or yes?
From what I'm aware, we have the test within the week, or the third test.
Yes. So I had the practice test I'm going to give out here a little later. Yay!
Well, what's it on? What sections of the homework?
3.9 through 4.7. So 4.8 and 4.9 and so forth are going to be on the next test. Yeah. We're only going to make it through 4.7 tonight. I guess, unless you want to go to 4.8. Okay. So what you should be going is like, oh, okay, thanks. 3.9 through 4.7. That's going to be the next test. Yes?
Are there going to be any quizzes?
if I gave a quiz on Wednesday, I'd be done grading it by Monday, but then Monday's the test. So, no. Yeah. So the last time I give a quiz would be a week before the test, because then you actually have time to get back. Yes?
4-1 on number 6. For the absolute max, do we say, like, because it doesn't include 0, so should we say the point that's like right after?
Here.
Yeah,
So what's your question? Sorry.
like when we're talking about the absolute max, do we
Yeah.
say like the point that is the closest,
Nope.
but not?
Nope. Because there's no such point. If you think you have it, I'm going to go halfway closer. And I could do that forever. So, where does it want there to be a maximum?
The closest is 0, 5.
If there were no open circles, where would the maximum be?
0,
And it would be at 0, and what would it be? It would be 5. That is the only candidate for the absolute maximum, correct? Does it exist?
Nope.
Nope. So what's the absolute max then? There
There's
isn't
none.
one.
What about the point under?
What is the point under it? Tell me exactly what it is. Okay, I'll stop. There isn't one. So you can't answer a question like that with a limiting process. In fact, the limit would get you to 5, but 5 doesn't exist. So the only possible absolute maximum could be 5. And it does not exist. So there is no absolute max. Yes.
And the min would be
The min is great. The absolute min is fantastic.
4, 1, right?
So.
Yeah, it would occur at 4, and the value would be 1. Is that cool? The absolute min is perfect. Is this differentiable?
Nope.
Who gives a shit? It exists. That's all that matters, right? There is an absolute min. But this highlights the fact. Do you guys agree this is a local min also?
No.
Oh, some people disagree. Locally, is it the lowest point? All right, so is it a local min? Yes, okay. How do I find where do local mins occur? Critical numbers. And how do I find critical numbers?
Derivative.
Where the derivative is
0
0?
or undefined?
Undefined. What situation is this?
Undefined.
Undefined. It's not differentiable there. So all that makes sense then. Critical numbers can occur where the slope is 0. That would be your normal kind of like, oh. Or it could occur where the derivative is undefined, where it's got the freaky kinks in it. Don't judge. Okay. Is that all right for that, Brian? So that's a really freaky one. When there's open circles, we know open circles always throws things off. It throws absolute maxes off and mins for sure. That was the only candidate. It doesn't exist. There's none. Yeah. The weird thing is second place would be itself because it would be a limiting process. And the limit, it would be 5. And that doesn't exist. So again, there you go. No winner. Yeah.
Real quick, you had that test coming out, you said it was 3947,
Yes.
4.5, we haven't touched on that.
We have today. We have today. Yes.
Would the next local max be 3, 4?
Yeah, another local, a local max, one would be 3, would be at 3, and the value would be 4. Is there another local max?
But
No.
then the absolute
Is there another
max-
local max?
Yeah.
Yes. There's another.
Oh, right there.
Yes. Yeah.
But it's not an absolute max.
Where's there? How many local mins are there?
2.
There's one. One local min.
Yeah, one.
This again. This is freaky.
Oh,
This doesn't
yeah.
get to count. Poor little guy. Okay.
4.335. Or if you want to, if you
Which one? Sorry. I'm sorry. I skipped somebody, but go ahead.
4.335.
Oh, sketchy graph. Oh. So, tell me, can somebody tell me in words what this means?
That the slope is bigger than 0.
All right, now tell me less technically. The graph is always going
Up.
up. The graph is always going up.
Oh.
Yes? So if you can kind of, I love it. That says derivative is positive. That means slope is greater than 0. Slope is positive. That means it's increasing. That means it's always going up. So I keep taking it down, down, down until I'm just got like a bare bones, like English freaking just tell me what to do. So whatever I draw, at no point can it be going down. That's what that says. And what's this say?
That it has, that the concavity.
Concavity?
Less than.
Less than 0. So what's another way to say that?
Which means it'll have to be negative.
Is it happy or sad?
It's sad.
Sad. So it looks like this.
Okay.
It's got to be curved. It does, to have down concavity. Okay. To have downward concavity. Sounds like a yoga pose, but it isn't. I don't have to, this is the most obvious down concavity, yes?
Mm-hmm.
There it is. Do I have, there we go. This is also down concavity. That is also down concavity, yes?
Mm-hmm.
I could draw that same line segment, but I can give it up concavity. Very, very slightly. Poor little guy. He tried. He's like, I didn't want to exist. Go ahead. That's up concavity. So you don't have to have a complete parabola for it to be some concavity. You just have to have it curving down or curving up, right? Is that okay? Just to help you with how to graph this, because it said it's always increasing, but it's concave down. Yes? There's a function that does that. It has to be concave down. So it has to be concave down, but it has to be increasing. Yes? What function does that look like?
Natural.
One over S.
Square root. That's what I'm thinking about. Now you could argue it looks like natural log too, yeah. I like it. But what I was thinking about was square root, yeah. You don't have to name your function. You don't have to give it a function. You just have to graph it. But you guys see how isn't that always increasing? And isn't that concave down? Water would flow off. It wouldn't get collected. Okay, maybe. It never turns, but it's still concave down because it's curving down. It's not going down, it's curving down. Maybe. Yes. No.
So if we did on the worksheet where at the end it was concave down, but we made it like go down all the way,
Sure, that could happen.
how do you differentiate whether it just goes?
Well, this one I know doesn't because the first thing it said is it's got to always be increasing. So there's no way in hell it can do this. Yeah, there you go. That's all. That's it. I know it cannot decrease according to the specific problem we were doing, so it can never do this. Can a concave down do this? Yes. Can this function do that? No, it's supposed to never decrease. Okay. I get. Yes.
4.1, number 35, is that just like a really ugly problem, or is there a trick?
Is that like a what kind of problem? Ugly?
An ugly problem.
Oh, poor little guy. 4.1 number 35. So he said?
Yeah, 4.135.
Oh. Poor little dude. What's he want from you? Find the critical numbers. Aw. Okay. Yeah, I understand.
Oh, yeah.
Just brute force, yeah. Yep, take its derivative. Go to 10.
It's just horrible.
Let me see, how can I say this?
Bad.
How would you determine when the bottom is, I need you to understand, if you take the derivative, does everybody agree with me that the bottom would be y squared minus y plus 1 all squared? Because I'm using quotient rule then, right?
Yes.
And that would only give me a critical number if it could ever be 0, yes? How can I tell? Just by looking at it. I know I'm a math geek, but you guys are there with me, you're all in calculus. How do you know that never equals 0?
Because it's a parabola with the y-intercept at positive 1. Upward parabola.
So,
The leading
you
coefficient.
can have a line up there and go, it can go below and still be an up parabola.
Degree is low, the degree is higher on the bottom.
How would you make it equal 0? Can you factor it? Sorry.
No, not
You weren't
nicely.
saying what I was hoping to hear, but I don't know, you might have been saying something good. How do I get it equal to 0 if I can't factor it? How do you get a quadratic function to equal 0
formula.
if you can't factor it?
Quadratic formula.
That shit. Inside the square root is b squared minus 4ac, yes?
Mm-hmm.
What's b? B squared is 1 minus 4 times 1 times 1. 1 minus 4 is negative squared. A negative number is not real, so it can never be 0. Because we're only considering real numbers. Is that, you guys see what I'm saying?
So would that
So
be,
this problem is going to be slightly gross, but it actually kind of turns into a product rule because you only care about the top. The bottom doesn't give you answers. The only way the bottom could give me critical numbers is if it could ever equal 0, and we just saw that it can never equal 0. So I only care to make the top 0. That's the only way that can give me critical numbers. Are you guys at all aware? This is the kind of analysis that you need to take a breath and think about when you're looking at these things. Because I agree with you, you're like, God, that's going to be gross. What's going to be gross is it's got several parts to it. But the first thing I realized is, oh, the bottom doesn't mean shit. That's nowhere near as gross as it could have been. Yeah.
sorry, 60, so would that be the same situation where the bottom can't equal 0 because it's got, because if you use quadratic to solve, it's gonna include i's.
So this one says, find the absolute max and min. Okay, so you got to find the critical numbers, right?
Yep.
So the bottom, like you said, the bottom can't be 0. And when you take the derivative, the bottom is going to be itself squared, so it still can't be 0. Yeah. So you're not going to get any critical numbers from the bottom. It's going to all be based on what's on the top. Yeah. Beautiful. Tears. Yes.
What do you mean by like ignoring the bottom? Like, how does
So, looking at that one real quick. E to the x over 1 plus x squared. What's this guy's derivative?
E to the x
You have the derivative of the top times the bottom
times
minus
e to the x
e to the x times the derivative of the bottom.
times
Yes.
2x
All over.
all over 1 plus x squared squared.
Critical numbers come from where this is undefined. The only way this could be undefined is if the bottom is 0 and the bottom can't be 0. So I can effectively ignore it. What's the only way a fraction could be 0? Is if the top is 0. So then I can just focus on that. So effectively, screw the bottom. Because it only gives me answers if it becomes 0. Because where do my critical numbers happen? When the derivative is 0 or undefined. So when's the only time the bottom matters? If it could be 0. And my derivative, yeah, yes.
So how would we prove that the bottom can't be 0? Do you use factor or quadratic?
No. It's pretty cool. I mean, 1 plus x squared, can that be 0? 1 plus x squared, can that be 0 for real numbers?
No.
No, because x squared is at least 0, and when I add 1 to it, it's at least 1. And then when I square it, it's even worse. Because now it just gets more positive quicker. It's always positive then. It's definitely not 0. Okay, maybe? So there's no proof required. I can just see 1 plus x squared can't be 0. I really hope we can all see that, yes. If you try to solve it, 1 plus x squared equal to 0, what do you very quickly get?
You get
Yes,
something that's
and thank the
unreal.
gods, we're not doing calculus of imaginary numbers. We could. But I don't think we
No.
want to. Yeah,
Please no.
I won't do it. It's really neat.
I know we did it in pre-calc.
Well, we talked about complex numbers.
A
We didn't
little
do
bit.
calculus of imaginary numbers. Okay.
That is that Calc 2 or Calc 3?
No.
Not covered.
No, well, it's not covered.
Doesn't
in
it?
those. And those are the baby courses in math. Yes.
Doesn't calculus only go up to calc 3?
Well, you got something you could call Calc 4, but then it goes off after that. I mean, Calc 1, 2, and 3 are the first couple courses in a full math degree. So I mean,
It goes off.
they're the baby courses. So you have made it. Baby course in math. So I don't like to tell people that aren't in calculus, but this is basically where math starts. Math starts in calculus. If you ever go any further in mathematics than calculus, you'll say to yourself, how the hell did I do shit before I do calculus? Because everything is going to be integration and differentiation. And you're like, oh, good. But it is good. It's awesome. It's silly. Yes.
Why won't they just teach you that instead then?
Instead of what?
Instead of all the other nonsense they taught us before?
So it's kind of
Like
like
the
saying,
integrated
I wanna be in
math
the
stuff.
Olympics. Why didn't, before you taught me how to freaking crawl, why didn't you just show me how to jump over this damn thing? You're like, right? I mean, it's a silly cliche, but you do have to crawl before you can walk, before you can run, before you can jump, before you can do all that shit, yes. So all that stuff was necessary to get here, yes, okay. Alright, anything else from homework? I think that's good, okay. So let's do this. I want to review a little bit what we did last time. What was the last thing we talked about last time? You guys remember? You're all like, it was over a weekend ago,
Oh, it
French
was
dude.
Rolle's theorem and L'Hopital's.
Yeah, Rolle's theorem and mean value theorem was 4-2. 4-2. I'm gonna let that be not too bad. You guys
It was
gotta try that out.
L'Hopital's.
L'Hopital's is huge. Can you remind me anything about L'Hopital's rule besides?
Oh, it only happens with fractions.
Beautiful. Let me put those two together. L'Hopital's rule can only be applied when you have an indeterminate limit involving ratios. Holy shit. So, one thing we did last time was this guy. Is that indeterminate form? Well, let's see. What form is it in? As x goes to 0, what does x go to?
0.
Holy shit. As x goes to 0, what does natural log go to? As x goes to 0, what does natural log go to?
Infinity, right? Or negative?
Yes.
Negative infinity.
How would I ever remember that, Jeff? Graph. Just remember the graph. Well, that's what pre-calc is supposed to do. It's supposed to shove all these graphs in your head. So when you get to calculus, you got them right there. You just need a rough sketch, you got it. I like the way some of you guys are looking at me. You're looking at me like, that's what it's supposed to do. Do you all see how that's indeterminate? Because 0 times anything is 0, and anything times infinity is infinity. So what is 0 times infinity? Both 0 and infinity. I think that qualifies for indeterminate, correct? Every indeterminate rule ends up being like that. What do you get when you divide 0 by anything? 0. What do you get when you divide anything by 0? Infinity. So what is 0 divided by 0? Both. So every indeterminate form is kind of like two things, two extreme values at once. You're like, I don't know how to determine that. Well, there you go. Do it. So that is indeterminate form, yes? You guys see that? That is definitely an indeterminate form. Will L'Hopital's work on it?
Yes. No. No.
Because what you said up
No. Because
It's not-
it isn't a ratio.
it's not a ratio. So one of the last problems we did was exactly this one, if I remember correctly. How do I make that into a ratio? I can make anything in the universe into a ratio. And I don't mean just by putting a 1 underneath it. I mean a real ratio of functions, right?
Don't you like bring the x down to the bottom or
Yeah,
something?
so you can even rewrite it like this if you want to. Negative power means flip, correct?
Yes.
So if I force anything down or up that doesn't want to be there, it just becomes a negative power. Because it really wants to be on the other side. So a really silly way to look at that is, x likes it up top. If I put it on the bottom, it's not happy now. Yes?
So is it indeterminate because x never reaches 0?
No, it's indeterminate because that form cannot be determined. I can't determine the answer. Real quick, just to show you, don't write this. If I had this instead, yeah, I meant to make this a limit. Go away. Limit as x goes to 0. Don't even write this, just look at this. What's the limit as x goes to 0 of this? 1. What's the limit of this? Is that indeterminate? What's
No.
1 times negative infinity?
Negative infinity.
Yeah. Do you see what I mean? So this is indeterminate because 0 times anything is 0, but anything times infinity is infinity. So 0 times infinity is, I don't know. Hard drive error. Okay. Is this a ratio now? What form is it in? What's the top go to? Negative infinity. What's the bottom go to? No. I I wrote it as x to the negative 1, but that's also 1 over x, correct? And what happens when x goes to 0 of 1 over x? Infinity. So that is indeterminate still, right? And that, in fact, that's one of our first indeterminate forms we ever saw. 0 over 0, infinity over infinity. Those are the old hits, right? The band's gonna play, they better play those. Will L'Hopital's rule work now? Why?
Yes.
2 things. Have a
Because it's a
ratio,
ratio.
and it's
And it's
indeterminate form.
indeterminate.
I like it. So if I apply L'Hopital's, what the hell does he say? I put a little LH there for myself for later, so I see what the shit I did, and for the person who's grading your stuff. Dear God, tell me what you did. You with me? Or don't. Let's see what happens. Okay. So how do I apply L'Hopital's rule? What's it say to do? So now we know I can apply it. What does it say to do?
You take the derivative of the top
Derivative of the top of x
and
is not
the
quotient
derivative
rule.
of the bottom.
It's just the derivative of the top divided by the derivative of the bottom. So what all L'Hopital says is something we've sort of been hinting at the entire time. It depends on who gets to infinity faster. That inherently tells me it should be based on a derivative. So it's kind of beautiful that it is. So what's the derivative of an ln x?
1 over x.
Bullshit. What's the derivative of x to the negative 1?
Negative x to the negative second.
Good. How do I simplify that?
X to the second over x.
Yes, totally. Yeah, multiplies out mod of x squared. I get negative x squared over x. And what's negative x squared over x?
X.
Negative x, and what's the limit is that?
X, yeah.
0. Done. Could I use L'Hopital's rule here?
No.
2 things. Why would you? Because it's not, and also because it isn't indeterminate and it's not a ratio. I mean, so be really, really careful. People start to get in this pattern where they take L'Hopital's and they kind of keep going until they get something nice. But you have to stop the minute it's not indeterminate anymore. Not just because you're doing too much work, but because literally it can make the answer wrong if it's not applied to an indeterminate form. If I don't stop, as soon as I get to a determinate form, I can get the completely wrong answer because it only works for sure if it's indeterminate. Maybe. Whatever you say, Jeff. So for example, what if I had this? Just a real quick example. Is that indeterminate?
Yes.
Is that the ratio? Yes.
Yes.
It's indeterminate, it's infinity or infinity, yes?
Mhm.
It's a ratio, so L'Hopital's works. I'll do the top. What's the derivative?
2x.
Holy shit. Is that still indeterminate? Yes, it's
Yeah.
infinity or infinity, right? So I can use L'Hopital's again, but people just do this before they check. So then I get what? I get limit as x goes to infinity.
E to the
x
x over 2.
2. Now if I do L'Hopital's again, in this case
It
I just
won't work.
happen to get something that sort of works out, but it only works for sure if what you currently have is indeterminate and is a ratio. So you could do it many times in a row, just before you do it, make sure you have a ratio that's indeterminate. If it's not indeterminate, why would you do anything except determine the answer? You're done, basically. Yeah. So what do we get here? Which is infinity, yeah. I always be really careful. If I ever see this, not to pick conversation, I'm sorry, you just happen to say this, but I see this all the time. I'm just like, whatever, man. I used to have somebody that just would not stop doing this, so I told him, just put this. Big freaking number. You cannot plug infinity in because infinity is not a number, it's a process. You cannot get to infinity. If you do, you put it in a suitcase and you give it to the people in Pulpit, because that's what the shit is. You can't get there. So even better than this shit, just say infinity because that's what it goes to. You guys understand? This is so cool. If you look back at almost any problem you did in chapter 2, we had to take a limit. You can start to notice you could do, the example last time with a cubic. Difference of cubes, everybody's favorite thing to factor. Well, now with L'Hopital's rule, it just kind of melts. It's gone. Maybe? Whatever you said. Sure, man. Yes.
So L'Hopital is just to get the limits of some of the undefined ratios that we didn't know?
Yes. So, like I told you last time, we never proved what this is. We used a table of values to approximate and say, it looks like it's going to 1. With L'Hopital's, we can prove it. Is that a polynomial that I can factor?
No.
Is there a polynomial there I can factor?
No.
Not until you take count 2, when you can make sin x become a polynomial. Teaser. If you never take count 2, you'll never know too bad. But for right now, that is not a polynomial I can factor. Yes? Is it indeterminate? Yes, 0 over 0.
Mhm.
We did this last time. What's the derivative of the top?
Cosine
Yeah, cosine over
over 1.
1. What's the cosine of 0?
1.
1. So now we proved what we actually just approximated or guessed at before. That was a guess before. It was a good guess. But now we can finally prove it. No, he's a very skinny person. He's got a little, one. Poor guy. What's that? Okay. You just go there. Freaked everybody out. Okay. So that's section 4.4 was L'Hopital's. Yes.
On the first example that you were doing where you had negative x squared over x,
Negative x squared over x.
yeah,
You mean this guy? No.
yeah, like that, right?
Yes.
Were we able to do it one more time?
Yes, you could. If you didn't realize you could just simplify it, you totally could. Then it would be negative 2x over 1. It would still be 0 when you plug 0 in. So, do you guys see if you didn't realize you could simplify this? You could use L'Hopital's rule again, because it still is indeterminate. But again, you always simplify before you do anything, right? If you give you a function and say do math calculus this, the first thing you do is, can I simplify the thing? Yeah, okay. All right, that's 4.4. 4.5 we already did. 4.5 is 4.3, and what's 4.3? 4.3 is take the derivative, make a sign diagram, see where it's going up and down, right? Yes?
Mhm.
Get the maxes and mins, take a second derivative, make a sign diagram, see where it's happy and sad. Yes?
Mhm.
Find the inflection points, find the mins and maxes. Are you guys all with me? That's 4.3. What 4.5 adds in is, first step is find the domain. One of your steps could be find the asymptotes, yes? Somebody very quickly remind me, what is the, how do you figure out the, you could do it, Jeff. I don't know, man. That'll work. Here, do this. Haha! What is the little 3 out front, yeah? Does anyone know what the horizontal asymptote is? What's the ha? 3. Y equals 3 to be more precise. So there's a horizontal asymptote, y equals 3. Where are the vertical asymptotes? How do you figure those out?
You set the bottom
Back to
equal
the
to
bottom,
0
make it equal to 0. So then you get horizontal asymptotes are where?
at 8 and negative 2.
At x equals 8, x equals negative 2. Four little dudes are lines, so they need a full line equation. You guys with me? So all 4.5 does is it says, hey, you didn't get enough of 4.3. Here's 4.3, but now with some pre-calculus thrown at you. Yes? It's going to ask you for asymptotes, domain, that kind of business. You guys with me? We did an example last time of a slant, didn't we?
Yeah,
Yes,
yeah, where we
yes.
had to do synthetic division.
Yes. Awesome. Okay. Let me stop for a minute, let that sink in. So we have done through section 4.5. 4.6 is not in our, I don't think I put that on our homework sheet. No, good, it's not in our curriculum. Right. So we're gonna get into 4.7. I love this. So, let's do this. Alright, since these are both gonna be on the test, 3.9 was related rates, yes. The reason people don't like 3.9, 2 reasons. Number one, they're word problems. And a word problem is a problem where they might not give you the function, you have to create your own. And that happened many times. In some related rates problems, they just gave us the formula. But there was still, like the one on the quiz, there's still some other stuff we have to do to adjust it, correct? So that's a word problem. We have to create out of nothing or modify a formula. That's a word problem. So number one, 3-9 kind of, students don't like it because it's word problems. And I don't blame them. We don't get enough practice with word problems. And you're like, yeah, I do. I know you don't. But secondly is because what am I taking derivatives with respect to in 3-9? Time. And in no formula did time show up. It was always behind the scenes, this little sneaky little dude in the back. Right? Keeps on slipping. So that meant if I have something like this, when I take derivatives, everybody is a, what are you trying to say? A chain rule. Right? Every variable that changes over time is a chain rule piece to be careful with, yes? That's section 3.9. Section 4.7 will be problems where that's not gonna happen. Because in section 4.7, we're not taking derivatives back to time. It's not letting time go. It's, I wanna create a rectangle and I have several different widths I can make. So the width is changing, and as I change the width, the length might change also. So then I'm taking the derivative with respect to width, or the derivative with respect to length, not the derivative with respect to some third variable that didn't even show up. Are you guys understanding? So 4.7 has that going for it. But it does push the tell me, ask me thing harder, yes, than 3.9 did. So what I wanna do, I have a handout that we talked about very briefly earlier.
What about
It's one of my most ambitious handouts, so some of you guys are gonna get part of this twice, but too bad.
what about section 4.6?
Oh, that's not in our curriculum.
Oh, okay. Guess we're not doing that.
Skip that one.
Yeah, that's up to him.
All right, so what I've tried to do. So if you've seen this before, the other side is different, which is nice. Yes. Gosh, zoom in, Jeff. Okay. So what I try to do when I teach this section, and 3.9 is the same idea, but like I said, this one's a little more in your face about it. They're gonna tell us something, and then they're gonna ask us something. The reason I try to teach it this way is because the hardest part about almost any math problem, but especially word problems, is for students to know how to break the problem up. I personally believe students think they're supposed to have the whole problem in their head at once. Or they just try to do it for some reason. I'm like, holy shit, I would go insane if I tried to do that. So you focus on pieces of it. So I'm trying to show you, kind of like if you try to teach me, if somebody could draw really well and try to teach me how to draw really well, you come up with ways for me to kind of like look at things correctly, whereas you could just see it maybe naturally. I'm like, I don't know. So I try to break the problem up into what they tell us. So you just focus completely on what they tell us. So this problem says, we're creating all these rectangles where the area is 25 square inches. So we're making all these different rectangles, yes? So one way I can create a triangle, can somebody give me one way to make a rectangle where the area is 25? The easiest way, of course, would be 5 by 5.
5 by 5.
Is that the only way?
No, you could do 1 by
I
25.
could do 1 by 25. Is that the only way?
Yeah.
No. I could do 10 by 2.5. Yes? You guys kind of with me? Yes. So for every time you change the length, doesn't that inherently change the width? Do you see what I was saying earlier? There's no letting time go by. Am I allowing time to go by and the rectangle is like growing or shrinking? That's not this. This is not that. As I change the length, the width must also change. Therefore, they are functions of each other. So I'm never going to take the derivative with respect to time in these problems. I'm going to take the derivative with respect to one of the two variables. Yes?
So when we're taking the exam to differentiate between optimization and related rates, is that we won't see it as time?
Beautiful. So a really key thing for related rates would be you see somewhere it says, and the height is changing by 4 centimeters per minute. You're like, oh, that's a rate of change over time. This is very likely a related rates problem. Yes? Okay, I like it. Also, optimization is the name of the game for these kind of word problems. The question is going to be find the biggest, find the least, find the thing that maximizes, find the thing that minimizes. It's going to be very overt, extreme. Find the extreme. Find the thing that makes the profit biggest. Find the thing that makes cost smallest. You know, you guys kind of find the way I can make the biggest area out of this. That's optimization. Getting into stop for a minute. Okay. So is everybody with me so far? So they're going to tell us something, focus all of your attention on that. Don't give a shit about find the smallest perimeter, don't give a shit about that. Focus on, okay, it's the area, let me draw a picture, let me find my variables, let me make an equation for that. Then you move to what they ask us about. And they ask us about the perimeter, correct? Yes, they ask us about the perimeter. So I need a formula for the perimeter. So from our picture, it's 2L plus 2W. No problem. They want us to minimize the perimeter. I notice I have 2 variables in there. I don't like it. So I'm going to rewrite it. So I use what they tell us to help me with what they ask us. I can solve this for which letter? Whatever you want. See, it's already a little better than 3.9. 3.9, you had to be careful. Which one do I want to solve for? It's the thing they told me about. This one is, I don't care. I just happen to solve for L, I think. Just because. At that moment, I felt that way. If it would have been a second later, maybe I solved for W. I don't know. So it doesn't matter. Whatever you do, you're going to get the one variable and then you'll get the other one. So if somebody sitting next to you did it the other way, they'll just get the one number and then they'll get the other number, different order than you did. They'll get the exact same answer, just a different order. You maybe? Yeah. So then I give you a different kind of problem here. And of course, I understand you are going to want to draw a picture, and I if I remember correctly, I did give you a way to do, I just did this in Paint, which was, you know, a lot of fun. But you need to be able to give yourself a little bit of an okay thing to have a visual anchor of what the hell's going on. Why did I make the base the way I did on this problem? What do you know about the base?
That it's
Square base. So of course the sides have to be the same length. Does the height have to be the same as that?
no.
Nope, nothing in there told me it was a cube or anything, so the height could be anything. The answer could be a cube, but I don't know. Now, something like this, I have 1,200 square centimeters of material. And be really careful about this open top. Can somebody tell me what the area is of the front face, the one that's facing us? No. Yeah, this one is facing me as XH, right? And how many of those do I have? 4. In the back one XH and this one's XH, yes? They're all X by H, yes?
Mm-hmm.
They all have a height and they all have the same X. So there's 4 XHs, yes? And the top is open, correct? So I don't need a lid. But what's the bottom? So now you see where this came from. I have 1x squared on the bottom and 4xh's around the outside, yes. That's how you do surface area. Surface area is a lot like perimeter. The only one you want a surface area formula for is a circle, because it's weird, but any other shape, surface area is just the area of every face added together. That's all it is. You with me? There's no formula to memorize. So whatever shape you got, just calculate the surface areas and add them together. That's the total surface area. So this is a real life problem. All right, this is tangentially related. Have any of you guys ever seen silos? You know what a silo is? Not a missile silo, but a silo, you might have corn in or peanuts. I grew up in Georgia. I was born in Georgia, left when I was 5. That's why only when I go back home do I get this accent, but it's gone. It's been buried underneath a lot of other shit. But a silo, what shape is it? Most of the time it's circular, because they've determined that that minimizes the surface area they need to contain the same amount of stuff in it. Especially little things like corn and so forth that fills. They had to put boxes in there. Obviously you want a rectangular shape to contain boxes, yes? Because then they go, but when they have stuff that'll fill up the area, a cylinder has more volume for the same surface area. You with me? So that's sort of tangentially related here. So we want to figure out, given a certain amount of material to work with, how do I make the damn thing hold the most? That makes sense, right? I'm going to say, especially if I'm going to make 80 million of these. If I maximize the volume of each, it's amazing. When I just maximize this crazy, multiply that by 18 million. Damn, I'm doing pretty well. You guys kind of with me? So this is a real life problem. Here I just plugged it in, this equal to 1200. What did you do, John? The volume, now that I've got the picture drawn, the volume is just length times width times height. And then I use what they tell me to help with what they ask me. Now let me ask you this. Can you guys see what variable is easiest to solve for? Do you want to solve for x?
No.
Can you see how solving for x would be, it looks impossible, but it would actually be just very, very hard. You could do it, but I don't want to do it. So it's much, much easier to solve this damn thing for h, correct? Subtract, divide, that's where I got the h from, yes? And then you plug what they tell you into what they ask you, and then I get something I can attack with calculus. If I'm trying to maximize this, I want to find the critical numbers. That means I have to take a derivative. Are you guys? Do you see how this kind of flows? Most of these problems have the same kind of flow to them. Ask me something, write that. Tell me something, write that. Use what they tell me, in what they ask me, attack it with calculus. Boom, boom, boom. Now I've done one little thing that I just realized that I haven't really talked about directly yet. So let me talk about that real quick. Oh, that's all, Jeff. Okay. Where do maxes and mins happen again?
Like critical points.
Critical numbers. So what if I have a critical number and I know it's concave down through that critical number? That's obviously going to be the location of a maximum, yes? So for example, let me see if I can come up with a quick example. Well, I can use this, yeah, you just use this one. What if I have and I want to find a critical number, so what would I do?
Set it equal to 0.
Yes, so thank God I'm taking real respect to x. Because as I construct this thing, I can change x. I don't have something and it's growing over time. It's changing because of my choice of how wide to make it or skinny to make the bottom. So this is the derivative with respect to how I change x. Thank the gods. Because there is zero freaking implicit chain rule shit going on. Yes? It's all in your face. What's the derivative of 300? What's the derivative of 1/4 x cubed?
3/4 x squared.
I like it. Can you take a moment and figure out the critical numbers for this? I like the reactions I get. I have very little water left. You should let us out early, Jeff. Be quiet. Of course, this is never undefined, so I completely focus on when this is 0. What part of that equation do you guys really not like?
The fraction.
Fraction. So if I just multiply everything by 4/3, the fraction goes away completely, right? Or you just do this, 300 equals 3/4 x squared. Whenever I have a fractional coefficient, I multiply by the reciprocal to kill it. Completely die bottom, die top. Die. And here, the 3 and the 4 just trade places. And what do I square to get 400? Holy shit. And now in this problem, I took it from the box problem. We're constructing this. If you can construct a negative side length, don't bring it. Take a picture of it. Right? Don't bring it, because I'm not sure what the hell's going to happen if you bring it. Don't bring black holes to school, kids. Okay, is everybody with me so far? This is a critical number. I don't know if this maximizes or minimizes. It could be either one. So one way you can determine it is to do what's called the second derivative test. Instead of making a sign diagram and doing the pluses and minuses, I can do what I just did, and if it's concave down, it's a max. If it's concave up through that point, it's a min. Does that make nothing but sense? If it's concave up through that point, it's a min. If it's concave down through that point, it's a max. So what is the second derivative? Let me rewrite the first derivative. Get in there. Was it 4x squared? 3/4 x squared. What's the second derivative? Yes, negative 3/2 x, is that cool? And what do you get when you plug a 20 in there? What do you get? You get a negative, so it's negative at x equal to 20. Therefore, it is concave down, and that's the location of a maximum. So that would maximize the point. Are you guys cool with it? So looking back at this handout, now you all understand what the hell I did. Here, I got the 20, and then I did the second derivative and saw that it's negative at x equal 20, so that means it's a maximum. So when would I like to do the second derivative test? Whenever the second derivative is easy. If the second derivative would be heinous, I'll just go ahead and make a freaking sign diagram, yes, for the first derivative. Because then I can see if it's going up and down and all that kind of stuff. You guys kind of with me? So this second derivative test is an option instead of doing the sign diagram. Especially if all I care about is it a max or a min at that point? That's all I don't care about where it's going up, where it's going down. I don't care about all that detail. I just want to know, is 20, does it maximize that or minimize that? Because I want the max. Yeah, got me. Okay. So, what I want you guys to do is to try to do this problem number 1.
I don't think I did it right.
Do as much of this as you can, and I'll catch up.
I don't think I did it right. So I ended up.
You said the length equals 180 over the area is in, but it's constant. The area is not going to change.
All right, let me make sure we're on the right track.
Just do L equals 180 over.
Part A, does it say anything about cost in Part A?
Yeah. No. Well, in the.
Because what do they tell us about? They tell us about the area, correct?
Uh-huh.
Does the area of the lot give a shit how much the fencing cost? No. So there's no cost showing up in Part A. It's all just the physical dimensions. So it's a rectangular lot. What do you guys want to call these?
W and L.
W and L? Okay. You just put them all over the place. So what's the area of that shape?
180
Good, what's the formula for it?
LW.
LW, so then therefore 180 equals LW. So that's an equation for what they tell us. And what they told us has nothing to do with the cost. Now, whenever you see one of these problems, when you say the question that says minimize the cost, eventually you've got to create a cost function. Because you can't minimize the cost unless you have a cost function. Then it can take a derivative of it. So if I say maximize the number of watermelons I can grow, okay, I need a function that models the number of watermelons I can grow, because then I can attack it with calculus. So then my whole focus is make that. So now part B, now I'm done with what they told us. What they told us just had to do with dimensions. Now I bring the cost in. Somebody tell me, which side did you pick to be?
The bottom side.
Bottom. You want that to be the expensive?
Yeah.
It doesn't matter. So how much does this side by itself cost?
15L.
15 times L, is that cool? $15 per foot. So if it was 2 feet long, it'd be $30. If it was 3 feet long, it'd be 45. It's L feet long, so it's 15L. Plus 10L
20.
plus
10W.
10W plus
Plan-
10W. So I got most expensive, 10 per, 10 per, 10 per.
You just do 20 W?
So totally. So now my cost function is, because before I do calculus, what do I do? Good. So I have 25L plus 20W. I want to be able to take derivatives. I don't like the fact that there's so many freaking
Variable.
variables. Let me stop for a minute. I think a decent number of you guys were heading this way, but some of you guys were veering away from this. So I want to make sure we're on track. So this is what I mean by there's a lot of cost information in this problem, but what they tell us has zero to do with cost. Okay. Keep going. Not yet. Now you want to use what they tell us in what they ask us.
Are we allowed to use that equation into the other one? Because that one is like.
What would
Like the units of 180 equals LW, right?
sure?
The 180 is in feet squared. But then if we put that length into the formula we had of like.
But if you divide 180 by W, you lose a foot, yes?
Yeah.
There you go. So the units worked out.
But like if we plug it into the equation that's in terms of cost, can we do that?
No, the cost is per foot. So if it's $15 per foot times feet, that's dollars. The feet cancel, yes?
Yeah.
Yes, okay. It's because it's that's much money per foot. So each expression is multiplied by a certain number of feet, so that's why it just becomes dollars. And of course, 180 divided by W is feet. Because it's square feet divided by feet, which is feet. So it works the same way. It just becomes money, yeah. But that's a really good point. You always want to make sure your units are matching up, because it's the quickest way to catch. Kind of like a silly mistake, like you put something in the wrong place. Yeah. Dave. What's C represent? Yeah, get rid of the thanks. Now, part C I told you what to solve for, just so we were all having the same thing to look at, but it doesn't matter if you solve for length or width, but I'm just asking you to solve for length, so we all have the same thing. Yeah.
I got forfeits W for L.
What?
Negative, okay, my ear. Trying to get that.
Okay, you're saying the cost is 0? That's the only way you can do here. Solve the area equation. What they tell us will help us with what they ask us. You can solve this equation. I can't solve this equation for L because there's 3 letters. 3 answers. Just lose that. what they tell us to help with what they ask us. Do you see how you assume C is 0?
Yeah.
You wish. Right? If you're fencing this off, you're like, we'll charge you. No. Yeah. Nope. So, area formula. Solve the area formula for L. Use what they tell us to help with what they ask us. You're solving the cost formula for L. You solve the area formula for L.
That's what I was doing, I was
Okay,
solving for
I
cost
did
for
that. So, do we have to find W before we do critical numbers?
Say again?
Are we finding W before we do the critical numbers?
Finding W. Oh. How do you mean? Do you have a cost formula now?
Yes.
Let's see. Catch up to you.
So I got to this, and then
Okay.
I solved over here
Gotcha.
for L
Then you took a derivative. I like it. And then you set this equal to.
equal to 0.
Good.
And then, okay.
4500 W to the negative 1. The negative W to the negative 2.
Then that's right. You said solve the area equation for L, so I switched it around.
Good. Beautiful. Perfect. Now you can attack this with calculus. Now you have a cost function that's a function of only one variable. You can attack it with differentiation. Good.
Oh, that does not work.
Wait.
So let's see. Here's my area equation. If I solve it for L, I get this. So in this problem, in this entire problem, L is 180 divided by W. If I see L anywhere in this problem, I can replace it with 180 over W. So specifically, I see it here. $25 times 180 is 50 times 90. It's 100 times 40. 4,500? Yeah. I'm gonna put the W up as a -1 power just to make it easier to look at. So here is my improved cost function. That is a better cost function because it only needs one input. Why does it only need one input?
Because it only has one
Because
variable.
there's a restraint on my shape. Whatever W is affects L and vice versa. So of course I should only have to know one variable to determine what this thing is. So my cost function should be able to put as a single variable function, and it is. Now I can attack it with calculus. And again, this is an optimization problem. That is not letting time go by. That now I'm going to take a derivative with respect to W, because that's what I can change. I can change the width, and if I change the width, the cost is going to change. You guys agree? Can't put that there. Can't put that there. Here. So if I take a derivative, what do I get?
Negative 4500.
Good. To the negative
2
2 plus
plus 20.
20. And then, real quick, is there a critical number you can see right now?
Yes.
I understand if you skip it because your brain says it doesn't mean shit, but what's the critical number I can see right now?
0.
0, because that would make this undefined, correct? But a width of 0 would give me an area of 0. So that's
So
the
it doesn't
other
make sense.
extreme. That is a critical. It's a location of extreme, but it'd be extreme bad. I'm paying a lot of money and getting no area out of it. Good job, Jeff. Definitely not getting fired from that job. Okay, so screw this. But I just want to point out there is a critical number there that leads to bad. That's the bad situation. So how do I find the other critical number?
Set it
Set
equal to 0, solve for W.
Exactamundo. How do I do that?
I brought the W back down,
Okay.
and then I added the fraction over, and then multiplied W squared by both sides, and then divided by 20, and then square rooted the
Get there. Is it
the
22.5?
225, yeah,
Okay.
and then that would give you plus or minus 15.
And of course, we know we're going to pick the positive because this is a physical situation.
I think it's just
Again, if you
no,
can-
it's just 225, not 22.5.
it's 4,500 now.
Oh,
It's
4,500.
4,500.
I lost the 0 already. Oh, my 0 is, I thought it was 1 0. So 225, that's better. Because what's the square root of 225?
15.
Look at that. All right.
So
I thought I
there's
made this nice. That's, yeah.
I think the critical number is a resting point.
Say again.
Like when we do the test, isn't it a resting point?
Well, let's see. The first derivative was this. If I take a second derivative, I'm going to get 9,000 w to the negative 3. Yes? And that looks to be positive. Yes? So it's concave up through this point. Therefore, this is a minimum.
But
It's concave up, so it looks like this. If it's concave up through a critical number, that critical number must be a minimum.
But when we do that test, like for
What
the
test?
derivative, like to find
Sine diagram?
Yeah, the sine.
Okay, sine diagram if you want to. You would put 225, right? I'm sorry, square rooted, we're gonna put 15. So if you put a 15 in there, you gotta work it out. We will work it out. 15 squared is 225. So you get 20, whatever the shit. So if you plug a 1 in, you'll get negative, and if you plug a billion in, you'll get positive. So it's going down, going up, that's a min. So even if you do the first derivative test, it'll still work. Put the critical number 15, plug a number in below 15, plug a number in above 15. Okay. That's what you think you did, show me after. So does everybody see this? Isn't this always greater than 0? Especially for widths greater than 0, which is the only ones we're allowed to use. So therefore, it's opening up. Therefore, this is a minimum. Now, what did I actually ask? Make sure the last step is make sure to answer the damn question. So I asked for the minimum cost. So don't just circle this and be cool with it because I want the cost. And thankfully, we have a cost function. And you can just plug 15 in. So what's that come out to be? 600? Yeah. So you get the cost is $600. That's the minimum cost. What's another way to check this? If I put 14 in, what should happen? It should be a higher cost. So you can do that. If I put 16 in, it should be a higher cost. So that's another way to kind of verify. Does that make sense? Yes.
So is that the minimum cost of the whole thing? Or
Yeah.
is it just
Yep. Now let me point something out. Was the answer a square? The width was 15, and the length would be 180 minus 15, which is not 15. Are you guys with me? So the answer was not a square, correct? Let me see if you guys are cool. Just go with me for a second. And you're like, that's all we ever do, Jeff. Let me say this again. The width was 15, and the length would be 120? No, I went the wrong way. 30? No. Help me out. 12? Okay, I'll take it. Oh, I added a 0. Good job, Jeff. So let me see if you guys really get me. Do you guys see the total cost in the W direction is 20 times 15? $300. And what's the total cost in the L direction? 25 times 12, $300. Do you see how it's 300 this way and 300 that way? So in terms of money, I don't know if you guys are going to understand what I'm about to say. In terms of money, it's a square. It's the same this way and that way. Does that help you solve the problem? Everything I just said was after we solved the problem. So I understand if you're like, I don't know what this crazy ass math dude is saying. But to me, it's really cool. Every answer is always a square for a four-sided figure in some way. Okay, enough of that. Sorry. Some of you guys are looking at me like, please stop. Okay.
Well, if you can get one length and one width.
Say again?
You can get one length and one width.
Of course.
Now you got 50 and 12.
Yeah.
Then that's a square because you're gonna have to do the exact same on the other side.
No. This is not a square because it's not the same length on all sides.
Well, if it was all the same length.
Then it would be a square.
Then it would be a square.
But this is
since you have
15 by
one
12,
side-
so it's not a square.
But since you have one side that is longer than the other three, you can't be a
No.
square.
These two sides are 15 and these two sides are 12. That's just reality. But when I bring cost into it, then it kind of has a different look to it. Then it's 300 this way, 300 that way. Okay, I'll stop. Okay. Look at this problem. This is one, and by the way, I'm gonna let us out a little early, so I'm just not gonna do a break. You know, like, oh, we like you even better, Jeff. Thank you so much. So let's go with it. This is another kind of problem you're gonna see in the homework, a few different places. And it's a problem I enjoy, so you're gonna see this probably on a quiz or a test. Find the square distance between any point on this graph and the point 2, -1. Now, let me ask you guys, does anyone know the distance formula between 2 points? Many of you should.
D squared equals x minus your
Well, yeah.
point.
It almost feels like you're gonna do slope, but
Is
it's
it
d squared
plus
equals
or
x2
minus?
minus x1 squared plus y2 minus y1 squared. It is just Pythagorean theorem. It's the difference in the x's squared plus the difference in the y squared equals the distance squared. It's just Pythagorean theorem. That's all it is. So let me see if I can get you guys on board. So let me write that down. Now, I know this point, so I'm going to call this x1, y1. What is x2, y2? Any
XY.
point, and it's not xy, because it's not allowed to be any point it wants to be. Where must it be?
On the graph.
It must be on the graph. So if I plug an x in, what do I get out?
A
You got
y.
f of x.
Which is?
X squared minus
Yes,
1.
so every point on that graph looks like this, yes? I need you to see this. If I plug a point in that function, I get x squared minus 1 out, whatever the x is I put in. So what's the distance then? What's the square distance? It would be x2 minus x1 squared plus y2
X squared minus 1.
minus y1 squared. Let me write this down here. What happens here? -1 minus -1
It cancel.
cancels. I'm just realizing that I didn't. Damn it, Jeff. Right, I'll be fine. I'm gonna be fine. I'm gonna be fine.
You sure?
Yes, we're all gonna be fine. Here we go. I just need some paper. Okay. So everybody with me so far? Okay, so what I want you to do right now. There's gonna be another problem in the homework. There's gonna be at least 1 or 2 in the homework that look like this. They give you a function and they ask you to find where it's the closest. And just so you guys see how this kind of makes sense, this of course is a parabola, and here's the point 2, -1. Somewhere it's closest to that thing, yes?
Mm-hmm.
So that's all what I'm asking is what point on the parabola is closest to that? Now, what I'm just realizing happened is I changed the function to work Because what we get there is an unfactorable, disgusting mess. So let's try this again from the top. Everybody get a new sheet of paper? So the function I'm gonna give you is this one. And it's gonna go through the point 2, -1. I did all this work to figure out a new thing, and then I forgot to update the sheet. I love it. So, the other point would be any x, but when I plug it in, I don't just get any y, I get specifically this, yes? So I'm gonna call this x1, y1, I'm gonna call this x2, y2, and then I get my distance squared. And now let me talk about the d squared in a second. So it'll be x minus 2 squared plus x to the 1/2 minus 1 minus -1 squared. Now I could take a big ass square root, correct? But let me see if you guys are cool with this. If I'm trying to minimize a number, what if instead I minimize the square of the number? Didn't I minimize the number then? If I minimize the square of a number, didn't I minimize the number itself? So instead of, aren't I gonna have to take a derivative at some point, correct? Because I'm gonna try to find the minimum distance. Do you want a big ass square root with a bunch of shit inside? That means you're gonna have to take some weird ass chain rule, which you should all be able to do if I make you. But my God, if I have a choice, I ain't gonna do that shit. So instead of taking a big ass square root, I just call this the distance squared function, and I'm gonna take its derivative. Much better. Why are we allowed to do that? Because if I find the minimum distance squared, I found the minimum distance. And that's all I want to do. Let's see if you guys are really cool with this. So this is not something squared. This is a function. This is the d squared function. Let me write this again because I want to make it look a little better. What is, these cancel, yes?
Yep.
And then what is x to the 1/2 squared?
1.
X, I like it. So you don't need parentheses, but you got it. So now I'm going to take a derivative. Dear God, don't do 2d d prime, because I'm taking the derivative of the d squared function. Just like y prime. What's the derivative of this? Good, 2 comes down. Here the inside is 1, kick ass. Plus 1. So, on number 2, the question said find the minimum distance. We created a distance squared formula. Then I can attack it with calculus. So if I say find the maximum blank, make a formula for blank, take its derivative, critical numbers, go to 10. So how do I find this guy's critical numbers?
Set it equal to 0.
So it equals 0 and you get?
X equals 3
3
halves.
halves. I like it. And just to make sure we answer the question, find the point that is closest. So how do I find the point?
So then you plug that value back into the original.
Yes,
f of
somebody help me
x.
out. Can you approximate that? What's the square root of 3 halves minus 1?
No.
Yes, you can, because you just make this thing do it.
I don't want to.
Square root of 3 halves minus 1. That was a lot of work. Okay. 225 roughly, yeah. Now, just to show you a nice visual of this. All right, let me make sure you guys all got that. So what did I do? This is a lot easier problem because there's a lot less going on. Create a distance formula, check. Attack it with calculus, check. Find the critical numbers, check. The one thing I didn't do here was verify this was a minimum. But let me just show you, this is kind of nifty. See if you guys agree. What I've done, what have I done? I've done this. I did this. Do you guys see? There's my, what point is this? 2, -1, right?
Mm-hmm.
So you see what I'm modeling. What's the green line? That's the distance between 2, -1 and the curve. So this is exactly what the question is asking for, correct? Which is another reason why I wanted to change it. Do you guys see how it's pretty long, but do you see how it gets shorter? Mm-hmm. And then somewhere in there, it's the shortest, yes? Does everybody agree? Somewhere in there, it's the shortest, yes? Well, of course, we already figured out it's 1.5. right? This point right there, and I don't think it's gonna tell me what that is. Too bad for everybody. Let me do this. Dude, look at that! 225, just like that, oh shit. I don't know if you guys are with me. So this is physically what we're doing. Of course, when it goes beyond that, it gives up. It's like, nope. And then it's like, oh, okay, it exists now. So this is visually what we just did. Is we got the distance of this for everything, and then we minimized it. Yes. Maybe. No.
So we found the slope of the distance, right?
No, well, yes, we found the distance formula. We took its derivative.
Okay.
So we can find its critical numbers. So derivative is slope. But a better way to look at this, if I want to minimize the number of bees in my garden, yes? And then for somehow I can figure out variables and I can set up an equation for the number of bees in my garden. Maybe it's related to the number of certain plants I have. You with me? Maybe certain plants chases them away. You with me? So I have a function that models the number of bees in my garden. I can take the derivative, find the critical numbers, and get the minimum. So I'm not going to think of it as a slope of bees. Because in this instance, yes, it is the slope of the number of bees, but does that help me understand it physically? No. Instead, I think of it as, if I find the derivative, I can get the critical numbers, and that's where the minimum could occur. Right? It still means slope, I agree with you, but it's better to just think directly to construct a function for the thing I want to minimize or maximize. Attack it with derivative, get the critical numbers, because that's where it could be minimum or maximum. Yeah. Don't forget that an answer could occur where it's got an undefined slope too. So you always want to find those critical numbers also. Okay, maybe. I don't know if you guys would believe me, but normally this section is a little less hated than related rates because there's no real like implicit chain rule things. There could be chain rule, but not like hidden behind the scenes, you know, like at time. Appreciate that. Okay. So let me give you this. 7 problems on here I want you to work out really quickly. I'm joking. This is the practice test.
Are there any on here that we're not doing? Because usually there are. Yep, I'm gonna do this, and 4.2, and 4.4, and 4.5, and 4.7.
No. I created it. I'm sorry.
Are there any that we're crossing off?
That's the slope at any given A times x minus x1 plus y1. So that is the slope, that is the tangent line formula for, but that's got any A. So yeah.
Wait, so is that something we figured out?
And I only let it live between, that's why it's only a segment. Do you have to understand everything I did there? No. That's all I did. I found the area, I found the line equation at A. Not at 3, not at 4, at A. And then I plugged it in.
Is that based on the function we had?
Of course, it has to. Yeah, that's why it relates to that function.
So
What's the relative extrema again? Isn't that just absolute max and mins?
So guys, a couple of things. Guys, a couple of things. This is the kind of optimization problems. I just wasn't feeling creative, so I just picked some out of the books. There's some L'Hopital's possibilities here, yes. Or you could do this one a different way, but it's up to you. There's mean value theorem stuff, right? That's section 4.2. Absolute, real quick, absolute extreme values. So when I say relative extrema, relative extrema, that's local maxes and mins. Because relative to their immediate surroundings, that's a maximum, even if it does this. That is still a local maximum. It's still a relative maximum, even though this guy's like, you suck. This guy's like, I'm fine. Right? The won the local championship instead of the national. You guys kind of with me? You don't have to have your function talk to you. So absolute extreme values kick so much ass. Does anyone remember why? Where can an absolute extreme value happen?
At endpoint.
Critical points or endpoints. Critical points come from where it's 0 or undefined the derivative, right? All you do is you find the critical points and then you plug those in with the endpoints. Now, real quick on part A, 2 things. Can everybody please right now, I didn't want to make this a trick question, make this g of x before I go crazy. Right, it's g of x. On part A, if one of my critical numbers is 7, I'm gonna plug that in.
Nope.
Why not?
Because
It's
that would make
it didn't
it
meet
0.
the requirements to get into the contest. If one of my critical numbers is -2, I'm gonna plug that in.
No. Yes.
-2.
Yeah.
Of course I will, because it met the requirements. It could be a winner. So you find the critical numbers, and then just plug those in with the endpoint and see who wins. Who wins biggest, who wins least. Absolute extreme values kick so much ass. Local, you've got to make a sign diagram, see if it's going up or down, all that kind of crap, right? Absolute is like, thank the gods, just plug shit in and see who wins. Yes? Yes.
You need to do. So I guess you gotta do derivatives. You need to do second derivative as well.
No, not for these.
Yeah.
Yeah. For this one, you definitely do. As I say to.
Yeah.
And for this one, of course, for concavity.
Okay.
So this is the one like 4.3 and 4.5? This here? And number 1 is like what we have on the quiz.
Alright.
So anything, I can let us out right now if you guys are ready. And then Wednesday, I'll have the answer key. It'll be review day. Okay. So this test will go up through 4.7. 4.8 and 4.9 will be included on the next test. We'll talk about those next sometime. You all right, sir?